These technicians are checking for wire insulation degradation. Such tests have become necessary on wires used for relay room and location wiring, which were manufactured before 1986 to BR specification 872. It has been found that under certain conditions the rubber insulation can deteriorate prematurely, causing it to break up or liquefy, leaving the conductor exposed. Single internal wires and those in warm areas are the most at risk. The condition of each wire now has to be checked thoroughly by specially trained examiners before any work can be carried out which might subject it to mechanical stress. Extremely delicate handling is needed. Cable and wire produced since 1986 is not affected by the problem. Manufactured by AEI, Pirelli General and BICC, the 872 specification wire has an inner insulating layer of green or blue-colored natural isoprene rubber, VIR, and a black PCP covering.
Rubber insulation deteriorates in one of two ways, either wet deterioration or dry deterioration. Both are caused by a chemical reaction with the inner layer of insulation over the wire. Wet insulation emanates predominantly from the termination of the wire, and it affects cables manufactured in the early 70s. And the degradation looks rather like the inner layer of insulation turning into a paint-like consistency. Dry insulation deterioration is a little more common, and again is caused by chemical deterioration of that inner layer of insulation, and it's where the insulation turns into a powdery-like consistency, losing all its mechanical strength. But both types are rather difficult to detect. Dry insulation affects cables mainly made between 1982 and 84 by Pirelli and AEI. This is a sample of wire that's got dry insulation failure, and at first sight the wire appears to be in good condition and in fact would provide good insulation if you didn't touch it. It's when you begin to move it or pull it or stretch it that you begin to have problems. And when you do stretch the insulation, you can feel that the inner insulation has gone all dry and powdery. These are samples of insulation. The first one is normal insulation, and if we have a look inside, we see that the longitudinal ridges are there as the cable has been made. The insulation material has flowed around the wire itself and formed the longitudinal ridges. And this blue material is quite pliable and normal. The next one is where dry insulation has just begun to start. You can see that it's beginning to crack up, that there's a slight powderiness in this texture. It's very much harder. The blue material is very much harder than in the last sample. And the final example is one where dry insulation is well advanced. You can see that there's no pliability in the blue material at all, and as I stretch it, it just breaks up and goes into a powdery form. You'll soon see whether you've got wet degradation. The outer insulation moves very freely on this gooey blue stuff inside. You can see the inner insulation oozing out from the end and glistening. And when you split it open, the blue stuff is just like oil paint. Surface degradation happens by the action of sunlight and atmospheric ozone, but careful control of the formulation of the PCP, the outer rubber, generally keeps that under control. The inner material, up to 1986, consisted of isoprene as the inner insulator, and that was affected by the migration of copper ions from the copper of the wire through the tin plating. In common with a lot of chemical reactions, this deterioration is accelerated by increased temperature, and some BR872 cables are more susceptible to it than others. What our studies have definitely shown is that any BR872 wire which passes above or very near to heat sources, such as wall heaters or power supplies, is particularly vulnerable. The same goes for wires in areas which have poor air circulation, such as those in a duct, for instance. Cables and wires manufactured after 1986, and that includes all our present supplies, are not affected by this problem because they use different compounds.
Comprehensive procedures have now been implemented for identifying and dealing with insulation degradation. All relay rooms and relocatable equipment buildings, REBs, and locations where BR872 wire is installed must be inspected for degradation every 2 years. No alterations or amendments to circuitry involving these wires should be carried out until the condition of the insulation has been established. Special examiners are being appointed and trained to carry out the checks. The examiners' reports will be used to build up a historical profile for each interlocking. This will include details of initial commissioning and significant alterations, a sketch plan of the accommodation showing the layout of racks and wireways and the position of heat sources, and as much information about the wire itself, such as the name of the manufacturer and year of make. A careful visual examination should be made of each installation phase, especially where wires pass through vulnerable areas. Highlight any positions which will require special attention during future inspections, and remember to look closely at areas which have restricted air circulation. Having identified those wires which are most likely to have degraded, and do not assume that the oldest will be the worst, arrangements can then be made to start renewing them. A useful test for degradation is to grip a short section of a longer piece of wire between the thumb and forefinger with each hand. With good insulation, the sample feels elastic and no damage is done. With a degraded sample, more movement can be achieved, and the roughness of the hardened insulation being pulled along the conductor can be felt in the fingers. At locations where degradation is identified, further samples must be taken immediately. In relay rooms, a minimum of 6 wires must be obtained, and in REBs, 2. No further work shall be carried out in the affected installation without the permission of the signalling maintenance engineer. In cases of severe degradation, the SME will arrange to have a further label attached to the rack or equipment affected, and a safe method of working adopted. When degradation is dangerous, in other words, if the conductors are exposed, all work must cease and steps taken to have the wire replaced. It may mean having to disconnect the signaling circuits. If there is doubt as to whether all wiring is affected, the whole installation should be rewired. When degradation is severe, or if a disturbance of the wires is likely to create a dangerous situation, a supervisor must be present throughout the work. The earth leakage detectors must be fitted and tests for earths made at the start and finish of work on each shift. When degradation is present but not severe, work may continue, providing the earth leakage detectors have again been fitted and the same tests are made.